Okay, so this data task is about responding to stimuli. The first investigation is looking at 3 different age groups, so to see if age and gender, because it's men and women, affect the reaction time. Okay, so what conclusions can you draw from what we've got? Well, first of all, hopefully you can see that generally, as the age groups increase, the reaction time, or the mean reaction time, also increases. So for the first question, the first mark would be reaction time increases with age. And the second mark would be the increase is greater between the middle and old age groups than young to middle age groups. So you can see there's a bigger jump here than here. So the increase is bigger between middle and old to between young and middle age groups. So what other conclusions can you make from the graph? So we're looking to see if we've got, using the standard deviation on the error bars. So what conclusions can we make? So first of all, we can see in the 20 to 30 age group, there's no overlap between men and women, so there is a significant difference in the mean reaction time in men and women. So men have got a significantly faster or shorter reaction time than women for the young age group. But for both the middle age group and the older age group, there is an overlap in standard deviations. So men and women, there's no significant difference between men and women. So they've got a similar reaction time. Also, we don't have a statistical test, so we can't prove if the differences are due to chance, or if we can't prove the level of probability that the differences are due to chance. We can't definitely see that they're significant. So one more thing you can take from this graph, which is on the next. So also for question 2, what conclusions can you take? And this might look a little bit confusing, but you can also look to see if there's an overlap between age groups rather than between men and women. And you can see for men, when looking at men, there's no overlap between there and there. There's no overlap between the top of this bar and the bottom of that bar. So there's a significant difference between each age group for men because there's no overlap in error bars. It's the same for women. The top of that bar, no overlap with the bottom of that bar. The top of that bar, there's no overlap with the bottom of that bar. So there's a significant difference as you go between age groups in women as well. Okay, so then the second study, they're looking to see if caffeine affects sort of driving performance. So what can we take from the text? So 7 should immediately leap out of us. Small sample size, not representative. We've controlled gender and we've controlled age. And from the last study, it just shows that both of those can affect reaction time, so it could affect driving performance. So it's controlled, that'll allow comparison. However, both if you're just using men and just using one age group, it's not actually representative of the whole population. If you wanted to make an announcement to say that the whole population would have a certain effect, it would have a certain effect on the whole population. Also notice that the control test is a decaffeinated coffee. So testing the effect of caffeine, and the control it has to look the same. So there's no psychological, to prove there's no psychological effect. So it has to look like coffee, just without the drug, in this case caffeine, in it. So decaffeinated coffee, everything else must be kept the same. And this allows you to prove that it is the caffeine in the coffee that has the effect on driver performance. So it's important to note that you can't just have no control or water. It has to look the same so that you can prove that it's not a psychological effect of having coffee. And this allows us to prove that it is the caffeine that causes the effect. If we just look at the table, we can see that the mean is higher for decaffeinated coffee, so they cross the road more times, and they also have a higher mark time exceeding the speed limit. But straight away you should be able to spot there's no standard deviations plus or minus next to these numbers, and also there's no statistical test, no t-test being carried out between those, and no t-test carried out between those. So let's have a look at question 4. So the agreed points is, so the question, drinking decaffeinated coffee makes us all drive less safely. So that's the agreed points higher here and higher there. Lots of disagreed points, no statistical test or no t-test, so we don't know if there's a significant difference. Small sample size, so it's not representative. The question does say drinking decaffeinated coffee makes us all drive less safely, and we've only tested men, we've only tested young age groups, so we don't know the effects, if there's similar effects on older people or women. They might be affected differently. And also we don't know the dose of caffeine. I mean, it could be a ridiculously high dose of caffeine that you wouldn't normally find in coffee. So that also could affect the results. And the other thing is, as well, this is done in a simulator. So it does tell you here it's done in a simulator. So it's not as difficult as real driving. The results could be different.